All right, guys. So for this lecture, we're going to take a little bit of a look at blood typing. So let's go ahead and kind of jump into this one. So the main reason we need to kind of worry about blood typing is really to for blood donation and transfusion purposes. So if we have a large loss of blood, it can have some pretty severe consequences. So they usually say about a loss of 15 to 30% can simply just give you weakness. And a loss of more than that, so over 30%, can actually lead to shock, which eventually could become fatal. So the average human adult has somewhere between 9 to 12 liters of blood. 9 is usually about the average for most women, but that would be somebody who's about 5'5" and 150 pounds. And then men, that would be anywhere up to 12 liters. And again, the males that we're looking at is somebody who's about 6 foot and about 200 pounds. So it's a huge range depending on what you have, and that equates roughly to about 1.2 to 1.5 gallons of blood that a person has in their body. So the reason for this whole thing is that we want to be able to look at transfusion. It's one of the only ways to really replace blood quickly, and only one of the only ways to reduce the risk of either the weakness or shock due to that blood loss. And when we look at it, transfusion must be done essentially in the same blood group or a similar blood group, which is why people are really being asked to donate blood, because blood is one of those parts that we really have not been able to synthesize in a lab yet. So we need blood donations to be able to kind of keep that stockpile up. All right, so with blood grouping, what we're looking for is blood actually contains genetical proteins in it. A foreign protein, or what we call an antigen, would result in a attack by the immune system, and that's really how our immune system works anyway. Any protein that comes into the body that really doesn't belong to us, our immune system will mount a response to it. When we're looking at, say, like this COVID-19 virus, there's most viruses, pretty much all of them, I wouldn't say most, all viruses have a protein coat around the outside of them. And that protein coat is marked with little studs of protein, and those are what the virus actually used to enter cells. Well, that protein doesn't belong to us. Our body's immune system will actually go out, our white blood cells specifically will go out and try to attack that. And that's why, especially this mRNA vaccination is useful, because we can give people just the piece of mRNA that makes the protein without having to give them the virus. And in most cases, any kind of vaccination that you're given is either a dead virus, sometimes a weakened virus. So there are some live and some dead, because the body needs um, that kind of spur or jump start for the immune system. Or in the case of these mRNA vaccinations that we're now seeing come out, we've learned that we can simply just give the person the piece of mRNA. Our ribosomes inside of our cell will synthesize that protein. And then once they make it, our body realizes that, hey, that protein doesn't belong to us, and then goes out and attacks it, or at least that's how it should happen, and kind of in theory, and in most people that's how it works. All right, but what we're really looking at is we're trying to form antibodies against those antigens. So the antigen is the protein, the antibody is the white blood cell that would be formed in response to it. So with blood is typed using antibodies that will essentially cause the blood to clump. So the activity that we're going to have you guys do on Friday and Monday of next week, what they do is they take this little dish that has 3 little wells in it, all right, and then those 3 little wells are used to put drops of blood, and then on top of that, we're putting the antibody serum for each one of those different types of blood that we could see, all right, and when it clumps, we refer to that as agglutination. So it almost looks like curded milk, because it kind of clumps up in those little wells. With humans, there are over 30 common red blood cell antigens. The ones that we really only think about, and the ones you hear about the most, are the ABO antigens, right? Because they're the most vigorous reactions that we see when we do some sort of a transfusion. The other one then is an Rh factor. So you've probably heard of people being like A positive or A negative, or O positive or O negative. The A, B, or O is simply the type of antigen that they make. So somebody who's A makes the A antigen, all right? Somebody who's B makes the B antigen, and people who are O actually don't make any antigen. So there's no marker on O blood. So that's why a lot of times you hear of people who are O being sort of what we call the universal donor, because their blood doesn't contain that antigen. And then the Rh factor is just a further antigen that then is on top of that. You're positive if you have the antigen. You're negative if you simply don't have the antigen. Okay. All right, so blood grouping. So it's based on the presence of those two antigens, either type A or type B. And then you can see here type O essentially lacks that antigen and is the universal donor. So people that have type O, again, there's no marker on the outside of that blood, no protein marker. Type B has a protein marker. All right, they contain the B antigen on the outside. A contains the A antigen on the outside. And then there are people who can be both, type A and B, so they contain both antigens on the outside. People who are AB are a lot of times referred to as the universal recipient. The true universal donor is type O negative because there's nothing on that. There's no Rh factor antigen and there's no A or B antigen. People who are type AB positive are people who can actually receive any kind of blood possible in those cases. Okay, so we really kind of look at those based on what we have. All right, now if we look at this in terms of blood groupings, so antigens is the protein that they make. Antibody would be the antibody they produce in response to those antigens. So if they make the antigen, they don't make the antibody. But if they don't make that antigen, they make the antibody in response to that. So let's go ahead and try to fill this out here real quick for you guys. All right. So type A, all right, is going to make the A antigen. All right. Type B would make the B antigen. Type AB would make both A plus B. Okay. And type O makes no antigen. All right. Antibody in response, since the type A makes the A antigen, they actually make the B antibody. Type B, since they make the B protein, the antigen, they make the A antibody. Type AB doesn't make any antibodies because they have both antigens, and type O makes both A and B antigens. So, in terms of who can give blood to who, all right, we have to kind of look at this. So can somebody who's type A can give blood to somebody who is type A, all right? If they give blood to somebody who's type B, all right? If they were to give blood to somebody who's type B, the B antibodies would attack the A antigen and cause their blood to actually coagulate or agglutinate. People who are type B can give to type B, all right? People who are AB can give to A. They can give to AB because they can't give to both. If we give them to both, then one or the other will clump. People who are type O can give to type O. All right. They can only give to type O because, again, they produce both antibodies. All right. They can get from, so now these are people who can donate to them. So somebody who's type A can receive A blood and they can receive O blood because, again, there's no antigen here. We can only give the one that has the antigen. People who are type B can get blood from people who are type B, and they can receive blood from people who are type O. Okay. People who are AB can get A, B, AB, and they can get O. Okay. And then people who are O can only get from O. All right. When we tag in the Rh factors, we could even tag in positive and negative. So somebody who is A positive can get from A positive and negative. I think I've got a slide coming up that kind of looks at that as well. All right. But you have to kind of think about those as we go through those when we talk about Rh factors. But so the chart gets a little bit more messy when you do that. But this is really what you're kind of looking at here. Again, O would be kind of your universal donor there. Let me erase that real quick. In terms of who can donate to who and kind of distribution and what's more common and least common, this kind of shows you a little bit of that. And apologize here, I'll get this erased as I kind of continue to talk. So this shows you ratios of who has what. So type O, even though they can only give to type O is not very rare. All right, it does show up, shows up a little bit more common than others. Okay, so actually O positive people shows up about 38, almost 39% of the time. All right, type O negative is fairly rare. We only see people with about 7.7% of the time, people with type O negative blood. Somebody who is A positive, all right, again, it's pretty common. A negative is a little bit more rare, right? B positive, again, it's a little more rare. We don't see it quite as often, right? And then B negative is even more rare. AB positive, right, is actually fairly rare, but we tend to see a little bit more of that than others. The most rarest form of blood would be AB negative. And really what this comes down to is you would have to look at, say, like a Punnett square, if you guys kind of remember back to like bio. All right, so if I just do the Punnett square with AB, all right, so to be able to be AB, you would have to have a parent who has B, all right, and a parent who has A. Okay, and then that could fall into this category of AB. Now, if I make any one of these two positive, the minute I make them positive, it makes this AB positive. That's why AB positive shows up more often than AB negative. You would have to have two parents that are A negative and B negative, and those two alleles would have to show up in a box for that to happen. Same thing with O negative. You have to have parents who are O, and then their other allele is O negative to be able to show up into that. Just to give you an example, both of my parents are O positive, right? And I actually had this kind of not an argument, but a conversation with my dad the one time. So both of my parents are O. All right, crude drawing here. So my mom is O positive. My dad is O positive. All right, we might not know what this other allele for them is, but I know it because I'm actually O negative. So my other parents, their allele has to be O negative, all right? And then I'm the individual that shows up in this box down here at the bottom as being O negative. Okay. My dad, when we were kind of talking about it, I donated blood for the first time and found out I was O negative, and he's like, "That can't be." And then we had to pull out the Punnett square, take a look at it, and then he realized, "Oh, yeah, I guess that does work." So again, we're looking at those kind of different types of blood. Again, that's why O negative tends to be a little bit more receptive to that. I can even go back. Let's go do that, because I don't think I've got that coming up in any slides. Right? It just shows the different kind of percentages. Yeah. All right. So I want to go back real quick, because I want to take a look at this. So if we go through this and split this box, all right. So I'm going to kind of split each one of these boxes down the center. We're going to make this individual A negative. We'll make this side positive, positive, B negative. We'll make that positive. And then this would be A, B negative. And then this would be O negative. So then we can split these. Split those. We can split this one. And then we can split this one. Okay. So again, on this side, these people are going to make the A antigen, and then they're going to make the positive antigen. Okay. These individuals will make the A antigen, and then there will be no Rh factor. This person's going to make an A, or sorry, not an A. They're going to make a B positive, and then just a B with no antigen. This one makes AB, again, positive, and then AB with no antigen. This one is O positive, and then O and no other antigen. So the antibodies they're going to make here, this person would make an antibody, obviously, to B, all right, but only B. They wouldn't make it to the positive, okay? This individual is going to make an antibody to A, again, only to the A, not to the positive. This person over here who is A negative would also make it a antibody to A and an antibody to the positive Rh factor. I guess I should kind of, let's put this here. So up here in the corner, I'm going to do Rh factor. All right. People who are AB, all right, they're going to make an antibody to nothing, sorry. So no antibodies and no Rh antibody. Okay. So this would be none in this case. these people over here are going to make an antibody to just the Rh positive. Okay. People who are O, obviously, again, are going to make an antibody to A and to B. All right. And they are also over here going to make an antibody to A and B. And in this case, they would also make an antibody to the Rh factor. Okay. So giving blood, somebody who is A positive can give blood to A positive only. Okay. Somebody who's A negative can give blood to A positive and A negative. Okay. Somebody who is B, sorry, I didn't do this one. All right, this person is going to do sorry. And this person would also do an antibody to B. So this one would be A, so B positive, they're going to make 1, 2, and they'll make the antibodies to A. Okay. And then kind of jumping down here a little bit. So this one would be B, but they can only give to B positive. Okay. And then this one would be B positive as well as B negative. All right. People who are AB positive can only give to AB, so they can give to AB positive. I apologize. These individuals can also give to AB. These individuals can give to AB. Okay. This individual can give to AB. This individual can give to AB. All right. But they would give to neg. They would give to positive. All right. These guys could give to negative and positive. All right. So negative and positive there as well. And then these guys could only give to AB negative. All right. Which is why somebody who's A negative can only give to A negative. These guys can donate blood to A positive, B positive, and O positive, as well as AB positive. All right. These can only give to A negative, B negative, all right, AB negative, and they can give to O negative. All right. Sorry, these guys can give to everybody. So A positive, B positive, and then this can also be AB positive and negative. Okay. Receiving blood from, if you're A positive, you can only get blood. You can get blood from A positive and negative. Okay. If you're A negative, you can only get blood from A negative. If you're AB, so again, B would be B positive as well as negative. This one would be just B negative. AB could be AB positive. So this would be A positive, B positive, AB positive, AB negative. All right. And then we could also do the negatives of both A and B, and then you could do O positive and O negative. All right. AB negative, it can only get blood from A negative, B negative, and then AB negative, and then O negative. And then O negative can only get blood from O negative. All right. I apologize about this. I'll try to type this up a little bit better and send it out to you guys. Okay. All right. So going back into these, try to erase that a little bit better. So that kind of takes a look at just kind of percentages. Wish there was a better way to erase. Control E. Nope, it's not going to let me erase it. So we'll just kind of look at those. We already looked at that process. So all right, so we'll kind of go back and take a look at a little bit of this for you guys. So this just gives you some of the percentages. We'll kind of put them out there. So O positive is pretty common. It's about 46% of the population. So between O positive and O negative. So The good news is that there usually is going to be some sort of universal donor to be able to donate. A positive and negative comprises about 38% of the population, so it's pretty common as well. B positive and B negative is a little less common, and then AB positive and negative is obviously the least common, with AB negative being the smallest amount, B negative being next, and then A negative and O negative kind of following up those. All right. The Rh blood grouping is kind of named because of the presence of just that, again, that Rh antigen, so that protein that kind of shows up. Most Americans tend to be Rh positive. It's much more common because most the chances of having a parent that has both negative alleles is kind of a little bit less. And really the only problem occurs is when you mix Rh positive blood into a person who's Rh negative. We tend to see some issues with that. The Rh factor just kind of goes through the way that it was actually shown up. All right, it was done with a study with rhesus monkeys. We found out that protein kind of existed. The presence of the protein or the lack of the protein simply just makes somebody positive or negative. The same with the blood typing. So if you don't make the protein, you're said to be negative. If you make the protein, you're going to be positive. Somebody who is Rh positive can get blood, like we showed in the diagram just a few minutes ago, from both Rh positive and negative. And somebody who is negative can get blood from somebody who is only negative. So that's why O negative can only get O negative, AB negative can only get AB negative, as well as A negative and B negative and O negative. And somebody who is B negative, again, is only going to get blood from somebody who's B negative or O negative. And somebody who is A negative can get blood from somebody who is A negative and O negative. But that's the reason why there. Rh dangers. So there are some dangers during pregnancy that we can see, but it usually only happens when you have a mother who is Rh negative and a father who is Rh positive. There's a chance in those cases then the child is going to inherit the Rh positive blood. If that were to happen, then the mother's immune system would actually go out and attack that blood, usually eventually ending up into some issues with the fetus, and most often, a lot of times, the fetus would not make it. We know that now, so we can actually test for that. So if we have a mother who is Rh negative, we can test to make sure that the baby that she's carrying is not Rh positive. And if it happens to be where the baby is Rh positive, we can give them an immune serum called RhoGAM. All right, the RhoGAM essentially blocks the mother's immune system's ability to attack the Rh positive blood. If the mother is Rh positive, we don't have to worry about it. But if the mother is Rh negative, it does become a problem. And it really becomes a problem in the second pregnancy. The first pregnancy, usually we don't tend to see as many issues. But the second pregnancy, her immune system has been exposed to that Rh positive blood and now can mount immune response much faster. Okay, this is what kind of shows this here. Again, it really only makes a difference if the mother is negative and the father is positive. All right, and the baby also has to be positive. When that happens, again, we give the RhoGAM and it essentially desensitizes the mother's immune system. All right, so and kind of suppresses that response. When we type these, this is what I was talking about before. We essentially take a sample and we mix in the anti-A and anti-B. So anti-A essentially contains A antibodies and the anti-B contains B antibodies. So if you mix those into a serum and the blood does this, we know that that person contains those two antigens. So in this case, this is somebody who's type AB because both the A and the B, it reacted to both serums. All right. This person down here you can see is B. It only reacted to the B serum, didn't react to the A. This person here is A. Again, no reaction to B, only a reaction to A. And this person we know is O because there is no reaction. Okay, and that's how it essentially is done. It's done in the lab, not even done in the lab in most cases. It's done pretty quickly right by the bedside because it's an easy test to kind of run. We can do that really quickly. All right, cross-matching. So we're testing for that agglutination so that we can make sure that we can donate to somebody and not have an issue. This talks a little bit about kind of those, that chart we were looking at before. So somebody who is AB, O, all right. So if they have no ABO antigen and they have both A and B antibodies, they are type O. All right, you can see who they can donate to. Then they can donate to O, A, B, and AB. Somebody who has the A antigen and contains the B antibodies is somebody who is type A. Again, they can they would be able to receive blood from somebody who is O, A, but they can't get AB because then it would clot. All right. Somebody who's B is going to have the B antigen, A antibody, and they can, their blood type then is B, so they can get from O and then B. All right. They can't get AB because, again, AB would clot in their system. Somebody who is AB, right? No antibodies. All right, we can give from O, A, B, and AB. So again, that's why they're the universal donor there. Okay. All right. Again, we'll try to go through this as much as we can. If you guys have questions on this one, please make sure you're asking during class, and we'll try to kind of walk through that. I'm seeing if I can't find another chart, so maybe we can kind of type those up so you guys can kind of take a look at them. And you're also going to get a chance to see them in the lab coming up on Friday and Monday. Okay.